Hey folks, sorry I can't be here today with you. I have a meeting and there'll be a couple more like this during the semester. So I just thought I'd make a quick video. I'm here alone in the room. Nice thing about this lesson is it's super easy. You get a brain break from all that stuff we did with the hard trig, and this is just a plug and play formula. So today we're going to be calculating arc length. And these show up periodically on the provincial exam as 1-mark questions or 2-mark questions. So I just want you to be aware this formula is on your formula sheet, so you just need to know the parts of it. So S represents arc length, and theta represents angle measurement, but the angle is given always in radians. If it's not given to you in radians, you can't use it in the formula. You have to convert it to radians first and then use it in the formula. Must be radians. So if you have your handy dandy highlighter, this is one of those things that is a non-negotiable. And if you put it in as a degree, it will give you a wonky answer and you won't get marks for it. Again, it would be a 1-mark question. So make sure your angles, you're using radians. And then the R represents the radius of the circle. And so let's just do a little picture here. So I'm looking at this. An arc length. So if we have the center point here, a radius is from the center to the circumference, so the middle to the outside. And if it goes all the way across, if it goes from one side to the other side, passing through the center, that's the diameter. So radius is equal to the diameter divided by 2. I'm sure you all know that, but that's another little trick that they'll do is they'll give you the diameter in the question, and then you'll be expected to calculate the radius from it. So those are just little tips and tricks and things that you should know. So what an arc length is the distance between two radiuses. So this here, the highlighted piece there, that's your arc length. So really important that, remember that it goes through the center. If a line goes from here to here, that's not a radius, that's a chord. Different thing, doesn't have a ton of relation right now. So radius has to go through the center to the circumference, and the distance between two radiuses, is an arc length. So if you're wondering where all that stuff is, that's what it looks like. Okay, so just a note, if there are no units attached to the angle measure, so like theta is 2.5, that means it's in radians. This is why we harp so much on you about units of measure. Forgetting the degree symbol, not a big deal. Well, it is now because you have to live in both worlds of radians and degrees. So, got to figure that out. Okay, so what we're going to do in example 1 is we're just going to calculate theta. We're going to calculate theta here. Oh, that's bad. We're going to calculate this angle measurement. So when we do that, we're just going to use the formula. We're going to fill in what we know. And again, this formula is located on your formula sheet that I gave you at the beginning of the year. It'll be provided at the provincial exam. So the arc length is measured along the circumference between the two radiuses. I got to look that up. So that's my arc length. So that's going to go in for 15, is going to go in for S. I'm trying to solve for theta. I don't know it. And my radius is 6. Divide by 6. Divide by 6. Theta is going to be 5/2 or 2.5. If I take 3 out of both of those, I just reduced it. You could leave it as a fraction or you can leave it as 2.5. And this question doesn't ask, actually I put no words in this question, but this doesn't ask you to convert it to degrees. That'll be something that you're expected to know how to do, and that's nowhere on your formula sheet either. So do with that information what you will. You got to memorize that, how to do that. Okay, so now we're getting away from pictures. Find the arc length. So I know right away with the arc length, I'm finding the S of a bicycle wheel, given that the radius is 24 and has a central angle of 48 degrees. So this is one of those trick questions. Central angles are between two radiuses at the center of a circle. So this is a central angle. Nothing really special about that. But I'm going to have to convert to radians before I even start the question. All right, so if we remember from, geez Louise, I'm doing this lesson prior to us doing this. I don't have my filled in notes. Okay, do I remember how to do this? Yes, I do. It is going to be 48 times pi divided by 180. And so that's going to give me my angle in radians. So 48 times pi, that's going to be ugly. I don't really want to do that. I'm just going to reduce my fraction. Maybe I'll put it into a decimal. I'm finding an arc length, so maybe I'll just put this into a decimal. And so I'm sure I said this in the lessons where we were together, is that you need to use the pi button on your calculator. So for me, it's a second function button with my exponent button. So that's where it's located on this one. If I look at this calculator, it is, oh, I just saw it. Geez Louise. It's right, oh, let's see, it's right down here above the times 10 to the exponent x. Pi is not really related to any, like it's not an inverse function of anything, so you kind of have to search around your calculator to find the pi button. If it's up here, then it's a second function button. Okay, so I'm going to take 48, I'm going to times it by pi, and again I need to use my pi button, sorry you guys can't see that, and then I'm going to divide by 180, and I'm going to get an angle measurement of 0.837. If I'm going to go 5 digits, we're going to end up having to round. So the more digits you use, the more accurate you're going to be. Because we're using pi, it's not going to be super accurate because pi is a rational number. So we'll do our best. I'm going to go for 5 digits. You should use, you know what? No, we're going to use all the digits on there. So 5, 8, 0, 4, 1. And if you're wondering why I changed my mind on that one, it's because rounding should only be done in the final answer. And we're going to use all the digits here. So it's not a hard formula. So we're going to be okay. And this one doesn't trick me. It tells me that the radius is 24. And so if I use my handy dandy calculator and just take that answer and times it by 24, this is where I'm going to round. Let's round to 2 decimal places. 20.11. But I need a unit of measure here because this is a length. It's an arc length. So inches is going to be our unit of measure. So this is our answer. This was work we needed to do to use that formula. If you drop in the 48, you'll be wrong. You won't receive the mark. Because that's the big thing. Okay, Allison the alien walks along the equator of her planet, traveling at 12.3 skips. If the diameter of the planet is 16.4 skips, through what central angle did Allison travel to the nearest 1/10 of a degree? Okay. So this is like a 3-dimensional picture. So if Allison's walking along the equator, I don't think I can draw you a 3-dimensional one. I want to, but I don't think I can. Oh, maybe I can. I know you're going to be super impressed with it. Okay, there's my 3-dimensional circle. So Allison's walking on the outside. So really, that's just a different circumference. She's walking on the surface of her planet. So if I do my 2-dimensional circle, she's traveled 12.3 skips. And the diameter of the planet, so there's another trick, Diameter of the planet is 16.4. So I have to take the diameter and divide it by 2 to get the radius. So radius is going to be 8.2. So we know from the center to the circumference is 8.2. What we're looking for is that angle right in there. So we're going to just use the formula again. So we're going to have 12.3 as our arc length. We're solving for theta and times by a radius of 8.2. Divide both sides by 8.2. And theta is equal to 1.3 divided by 8.2 gives me 1.5. And if you walk away from the question at this point, then you have done half the work. So keep in mind, if in this formula, theta is measured in radians. You don't have to put this, but I'm going to write it in just because we're new to using radians, and it's always a good reminder to keep using, like, that no units means radians. You'll never get in trouble for writing radians, but we want it in degrees. So if we want to convert from a radian to a degree, so theta would be 1.5 times 180 divided by pi. And again, those would be your notes from 4.1. So make sure you look back on them. The way I remember it is radians on the unit circle usually have pi in them. So when I want to get to degrees, I have to divide out the pi. So I know it's on the bottom. But that's kind of how my brain works. And again, make sure you're using the pi button. So that's going to be 270 divided by pi. And again, we know we're going to have decimals because we're dividing by an irrational number. So I'm just going to show you my calculator here. 85.94, and it wants it to the nearest tenth of a degree. So this is going to be 85.9, and we have to use the degree symbol so to indicate that this is our answer in degrees. And we would have found similarly, did you like that? Similar, I can't speak today. Radians, there's a lot less of them in a circle. So 3.14 is halfway around the circle. So 1.5 is almost 90 degrees. Makes a little bit of sense. The more we relate things to stuff that we know, the better we're going to be at making sense of it. So this is just use of a formula and just converting back and forth between degrees and radians. That's all this lesson is. It's nice and quick. And we'll see you guys tomorrow, and we will do putting it all together on the unit circle. Okay, have a great day, guys.